Well, let's see. Is it polar?
Radio?
Yeah, it's on the radio. So number 27, is it polar or nonpolar? Well, for that, we've got to do some other things. For polar or nonpolar, we have to figure out the shape of the molecule. This is showing the shape of the bonds. For the molecule, then I've got four sets of electrons around the central atom. Okay? And you don't have to draw the circles around it. That's just a tool for me to be able to illustrate it for you. Sets can be 2 electrons, sets can be 4 electrons, sets can be 6 electrons. There are 2 electrons in a shared pair, okay, or 2 electrons in a lone pair. If you have a double bond, then you've got 4 electrons in a set. If you've got a triple bond, you've got 6 electrons in a set. In this case, we have 4 sets around a central atom, and the molecular shape, let's start with the electron pair shape. The electron pair shape that you get from 4 sets of electrons around a central atom is going to be tetrahedral. Okay, you got one going straight up. You're going to have an arm coming out this way that's going to be a little more. 90 goes this way, 120 is like this. We want it in between the two. You got one coming toward you about on that same axis here on the other side. So not quite, a little more than 90, not quite 120. And then a dotted line that also comes over here like that, just a little more than 90. Okay? And so we're going to put our lone pairs around it. And we call this the electron pair shape. That's the type of drawing it is. And it's a tetrahedral. Okay? Tetrahedral because of the way I've arranged the arms around that central atom. So it's a tetrahedral electron pair shape. Full name. Tetrahedral electron pair shape. Okay? From the tetrahedral electron pair shape, then, I want to get the next shape. And so I'm going to take and put those 4 arms around the central atom. And I'm going to put electron pairs on there, just like before. I'm going to redraw exactly the same drawing. And I suggest you do this in pencil. I'm doing it in a marker so you can see it more easily on the projector and on the video. But I suggest you do this in pencil every time. Because when we get to this step, what we want to do is to go back and look at our Lewis dot formula here and see how many of these sets of electrons are shared. And if the sets are shared, we want to erase those pairs of electrons and replace them with the atoms they're shared with. Well, there are 2 shared pairs. Okay? And so we need to erase 2 of the shared pairs and replace those 2 shared pairs with the symbols for the atoms that go there. So these 2 pairs of electrons are going to stay. Alright, so now we go to another shape one more time to get to the last shape we're going to need. Now sometimes you stop right there. If you've eliminated all your lone pairs or electron pairs, that's where you stop, but we haven't quite finished yet because we still got some electron pairs over here. So we're going to have our central atom. We're going to redraw exactly the same drawing. And again, I'm recommending you do this in pencil. When you get to this stage then, after we've gotten to this third drawing in this case, then we're ready to eliminate the lone pairs that remain. We've gotten down to this point, we're ready to do that. And now we have a molecular shape. Okay? So this is a tetrahedral electron pair shape. This is a tetrahedral modified electron pair shape. And this is a molecular shape. Its geometric name is bent. So this is a bent molecular shape. Okay? So once we've got the shape of the molecule, now we're ready to find out whether it's polar or not. So for that, we're going to need our periodic table of electronegativities and your test references. So here is a periodic table with electronegativities listed on it. And we've got sulfur here and chlorine there. Okay? And so for the bonds between sulfur and chlorine, I can see that chlorine has a higher electronegativity. So it's 3.16. That's the electronegativity for chlorine. and 2.58 is the electronegativity for sulfur, and I want to subtract, okay, to find the difference, the electronegativity difference. I'm looking for the electronegativity difference for a bond between sulfur and chlorine, okay? So let's see, I get 8 and 5. Is that correct? 0.58. All right. Since the range for polar bonds is between 0.5 and 1.5, that's the range for polar bonds. Okay. This number is in that range. Okay, nonpolar bonds are 0.3 or less. Ionic bonds, at least for this class, we're trying to use a rudimentary system here. Ionic would be 1.7 or above to infinity. But this is clearly in that polar range. Okay, and let's see. The chlorine is more electronegative, so my electronegativity sort of goes in this direction. All right. This is an uneven distribution. The bonds are not evenly distributed around that central atom. Okay. So that would make it, and if you have an uneven distribution and you have polar bonds, you've got to have both. One by itself doesn't do it. You have to have both. If you have both, then this is a polar molecule. Well, it's a sad-looking E on the end, but that's what it is. Molecule.
So it has to have what
you have to have, for it to be a polar molecule, in this class at this point in time, because there are, remember I said this earlier in the semester, there are other factors that affect polarity. We're using a very, very simple system because you're just beginning to understand polarity, okay? Polar molecules must have two things, and you have to have both. You have to have both polar bonds and an uneven distribution of those bonds. Okay? If you don't have both, then the molecule is nonpolar. Okay? Bent molecules have an uneven distribution. Trigonal, pyramidal have an uneven distribution. Okay, we don't get into it much in here, but let's see, what is that thing called? Tetrahedral. The one, and I forget, for some reason the name escapes me at the moment, where you have X and Y goes this way, and then you have a Y down here. No, it's a tetrahedral, but I just, for some reason, it's an unbalanced sort of tetrahedral. The name just escapes me at the moment. That's an uneven distribution. Okay, a lot of different uneven distributions are out there, but basically, if you don't have an even spread of all the bonds around that central atom, then that's an uneven distribution. Okay, and you've got to be able to think sort of in three dimensions. This one kind of requires you to think in three dimensions. A trigonal pyramidal requires you to kind of think in three dimensions to kind of see it in your mind the way this is shaped. Okay, that's an uneven distribution. Here's trigonal pyramidal. Okay? Questions about any of that? All right. So, make sure that I fully answer your question. Okay? The next question. No more questions? Am I going to give you an answer sheet? No. No. I'm not sure I understand what you're saying. You just need to know if your answers are correct? Okay, just ask. Well, so ask. No, I'm not going through every single one of them. Come on. No, I'm not going to do an answer sheet. I'm not going to do an answer sheet. Okay. Which ones are you absolutely not sure about? I mean, I hope, Jay Breezy, that you know the answer to number one. See, there you go. Okay. So that what you should do is, if you're absolutely sure and you've got all 5-unit handouts, okay, and if for those of you who hadn't figured it out, you can download those from the website and have electronic copies. And electronic copies you can search electronically, right? Right. So you just type in density and have it search for density through your handouts until you find the answer to the question. You know?
You can go through all the handouts and then anything you can figure it out.
Sure. If you
When you do that on your website, where do you search for it?
The handouts on the web pages, there's a web page just for honors chemistry.
Yeah.
And then on that page you'll find Unit 1, and under Unit 1 you're going to find the handout.
Yeah.
Then under Unit 2 you'll find the handout. It's one of the documents you can download. Okay? And if you have, if you have Adobe Acrobat Pro at home, you can combine all of those into one document and do a master search if you want to. Okay? If somebody were to email me and ask me to do it, I might even be inclined to do it for you and put it on the web, if you want me to. But I don't want to waste my time if it isn't going to help you. This is all multiple choice. Midterm test is all multiple choice. But if you think this is a memorize and repeat test, you're going to be sadly mistaken. You have to be able to solve problems to get the answers. So you were asking about 26 and 27. Well, those molecules aren't going to be on the test. It's going to be some other molecule, right?
Yep.
So there might be a question like 26 or 27 on the test. Okay, Thomas, this isn't important to you? What's the deal? Okay, just kind of pay attention up here, okay? All right, thank you. So what I'm going to have is, say, if I was asking about hybridization, well, let's see, SP, SP2, SP3, D might be SP3D, E might be SP3D2. Okay? Well, let's see, you can eliminate two of those right there because we never go through SP3D or SP3D2 in here, do we?
No.
That's college work stuff. Okay? So you can eliminate two of those already. You got to figure out just those three, right? So, and that question may not even be on there, but if there is one, it's a different molecule. You guys still got to figure it out. So you have to be able to do all this to answer the questions, and there are 75 questions on the midterm test. Some of them will be pretty quick, like might be something like number 1, okay, which is pretty quick. You should be able to. You should know right away. Density compares mass and volume. Boom.
Like on the test.
Mm-hmm.
On the test, is there room for us like workout problems?
I can give you work scratch paper to work with. Okay.